It's the 26th of May, a beautiful day in Los Angeles, 72 degrees. And today we're going to look at fact debate number 3 concerning climate change. We're going to examine the question, scientists, using computer models are able to accurately predict future climate events. I repeat, scientists using computer models are able to accurately predict future climate events. For the government, Austin Cady, Austin Cady, I won't even try this other name, Thao Chow Pan, okay, and for the opposition, Stephen Williams and Thijs Kruger. Close enough for government work. Okay. Okay, the chair will recognize the leader of the government for a speech not to exceed 7 minutes in length. Wow, you're tall. Look at this. Okay, sorry. Can we all back up a little? Yes, you may begin.
Now we want to start off with a simple analogy. Now imagine it's a normal day and you walk out of your house and you're going to go, you get in your car, you drive to work. It's a normal day. But now imagine the next day when you walk down to get in your car and scientists with computer models can tell you that there's a 90% chance that you're going to get into a car accident that day. Now yes, there is a 10% chance that you are totally fine when you get to work. But I guarantee you that no one here drives to work that day. That is the motivation that the affirmative side takes in this debate. We show that scientific models must not be completely accurate, but that they must be accurate enough to give us a reasonable prediction of how we should act in the future. That is why we on the affirmative side strongly believe that scientists using computer models are able to accurately predict future climate events. Now we start off with the criteria, and we believe that since this is a fact debate, what it should basically boil down to is the preponderance of meaningful evidence. Now the key word there being meaningful. It's not just who can spit out the most facts or the most new evidence, but the most meaningful evidence backed up by the most reasonable logic that will actually help us to make a decision. We go to our observation 1, which is the definitions that we have to go over because it is a fact debate. We look over scientists as qualified and reputable individuals who are conducting research based on the scientific method, so not just any crackpot giving you statistics. Computer-based models, just any form of mathematical model, accurately, and we're trying to stay away from solely mathematical things, so it's more like easier, more palatable, is that basically the majority of the time being able to determine within like 20% accuracy, but hopefully the numbers won't bog us down here. And then for the future, as we look at in the more near future, so things like the upcoming decade, so we're not going too far out there. Now we move on to observation 2, which is the burden on both sides of this debate. Now what we see is that the negative side must show you that on average, scientists using computer models cannot accurately predict the future. Not that there are flawed models. Because if scientists can take 20 flawed models and come up with an accurate prediction of the future, we still win this debate. So that is what we, on the affirmative, must show you. That using models, they can predict accurately the future. Now, because people say that basically these climate models being able to predict the future is one of the 6 largest contrarian myths, we want to first give you 4 reasons why you would normally doubt these models, and we will go forward and prove them wrong. The first being that humans are flawed, so aren't our models. Something that's brought forth by Lomborg and the skeptical environmentalists. We prove that wrong with our 4th observation, which I'll get to in a second. The second being that if we can't even predict the weather for the week, how can we predict climate change? The third being that previous models were unable to predict the slowdown in global warming, so how can they be accurate? And the fourth being that if we lack a mathematical basis for certain systems like clouds, how can we say we accurately predict? Now we will go forward and systematically prove each of those claims wrong and show you why you must grant the affirmative side adherence. So we go to our fourth observation, that perfection is not required. So they say that humans are flawed, so must our models. And we bite this bullet. Yes, our models will never be 100% accurate. We do not believe that that makes them inaccurate. Having small flaws is okay because by putting them together, by taking these harms, we can come up with accurate data. So we believe that this is the real reason that it doesn't really matter that we have a small amount of flaw in the human aspect because we can weigh these out. And the way that we can weigh these out is brought up in our fifth observation, which is the past does not equal the present. So just because we have had flawed models in the past does not mean that we will continue to have flawed models. So what we see as our subpoint A is that basically the new models shed light into actual climatic cycles. So think like the ENSO, the El Niño Southern Oscillation. So basically what these El Niño systems are is they're basically these weather cycles over the central eastern Pacific region, so around Mexico and that area. And you see that the weather changes a lot based on the wind patterns, and we haven't been able to predict those before. El Niño usually has higher temperatures, which leads to more rain in the Midwest. La Niña is cooler. And we see that we haven't previously been able to take this into account. But now we've seen that James Ribsey et al. Inside of Nature of 2014 in July published a study that by looking at El Niño patterns, he basically took a sliding scale model for every 15 years for the past, from 1880 to 2012. And he took 18 different of these models and he put them together. And what he found was he could find the exact trajectory, and he could create an accurate model if he knew the El Niño cycles. Now you may say, well, we don't know the El Niño cycles, or we would have been able to predict in the past. But what we've also seen is that Matt England et al. Published in Nature of February of 2014, an article that shows that they've actually been able to correctly link wind circulation to temperature changes. And this has confirmed the article published by Yuko Saka and Chang Pingji, sorry for the pronunciation botching, in Nature of August of 2013. What this shows is that now we can actually predict wind patterns, which lets us predict El Niño cycles, and we can accurately predict how weather will change in the future. This negates the point that we haven't been able to predict the slowdown in the past. Additionally, we see that by compiling more models, we result in more accurate prediction. This refutes the point about weather that comes up all the time. When you're trying to decide weather, it's a one-time thing. It's like flipping a coin once. You never know if it's going to be heads or tails, but you know overall what your statistics are. By taking when you look at a climate change, it's not just one day's events, but it's for 1,000 days events. So when you have the small mistakes over time, they eventually even out and you get an accurate model. That is why climate change is much different than weather forecasting, something that is often a misconception by people. We move to the sixth observation we have, which is missing math can still lead to accuracy. Because a major claim against global warming statistics is we don't have the basis. And we agree we don't necessarily have the basis. But we do not believe that this incomplete understanding equals a misunderstanding. So what we basically look at is an empirical example first. We look at the Navier-Stokes equations. What the Navier-Stokes equations are is they are a set of equations used to model the flow of viscous fluids in a system. Now it's interesting because the Navier-Stokes equation is also one of the 7th most important mathematical problems in the world and is one of the Clay Mathematics Millennium Goals, which means you get a $1 million prize if you can solve it, so guys, you should try for it. But basically, we still use these equations to help us model how our aircraft wings fly, how our cars drive, and all these other things. But what the problem is no one has actually been able to prove that viscous fluids even exist in a 3D world with the Navier-Stokes equation. That's what the problem is. We use it to model the planes that fly that carry us from place to place, but we can't actually prove that the basis of them are correct. What this shows us is an empirical example that just because we do not have the basis of things like the clouds does not mean that we cannot create an accurate model. What we see is that by having some of the more important elements of these models, we can create accurate predictions. That is what we have seen in papers like the James Ribsey paper I mentioned earlier in Nature. Additionally, we will show in my member's speech that the cloud models is actually a moot point because we actually have been able to start to predict the clouds. So what we have shown you is that just because humans are flawed does not mean, and our models are flawed, does not mean we don't give you results. We see that even by having flawed models, we can have accurate predictions. And that is why we strongly urge an affirmative ballot. Thank you.
I now stand open for cross-examination and points of clarification. Please come to the front of the podium for your cross-examination. Stand close together, please. Thank you. Okay, begin.
According to 2013 research by the University of Oklahoma, the public doesn't take hurricane or tornado warnings seriously because they are inaccurate. Do you agree that even though the predictions do not have to be 100% accurate, they are apparently not accurate enough to adequately warn the public?
I completely disagree with that statement.
You stated that the fact that past models were not accurate, this doesn't mean that future models could not be accurate. We are debating the accuracy of present models today, and do you think those are accurate considering, for example, the IPCC's 2014 models accuracy?
Oh, well, yes. What we've seen is that, and maybe not the IPCC's explicitly, but what we've shown is some of the new present models, like the James Ribsey paper that we published when joined with things like the Matt England paper. So basically they can use a sliding scale of, it's called the CMIP, which is a collaboration of all these different models. By putting them together and using a sliding scale, they've been able to actually already make accurate predictions. So whereas in the past they might, and maybe in the IPCC's, the actually forefront of these models are actually very accurate.
And you say in your brief that using ocean temperatures enables scientists to accurately predict climate change. But according to NASA, the main uncertainty in predicting climate change comes from inadequate representation of clouds in these models. Do you agree that this makes us unable to make accurate predictions?
I disagree. I do agree that there is definitely some uncertainty there. But what we actually have to see is in other places published by NASA, when you see that it actually made great strides. I believe the name is Matthew Theosis. I'll mention him later on throughout the debate. And basically what they've shown is by working at JPL, they can break up clouds into these small fragments, where instead of looking at cloud systems as a whole, which is what they did in the past, they've started to break them up kilometer by kilometer. And they've been able to already make great strides with it, from NASA themselves, actually, in one of their newest articles they published.
You also stated that missing math can lead to accuracy, but in this initial condition uncertainty, so the level of conditions that are being taken into account in these models isn't accounted for, which according to the National Research Center on Atmospherics accounts for nearly half of all the inaccuracies in climate change models. Do you think that this means that even with missing or false math, the inaccuracy is still very large?
I do not believe that the inaccuracies that we've had in the past is because of the missing basis of the math. I believe that the inaccuracies we've had in the past is because we didn't have the experience that we now have. Whereas before we may have had a lot of different models put together, what we see that we didn't actually get the compilation of them and the meta-analysis that result in a effective solution. That's something that has just come to the forefront. Whereas a lot of people may make mistakes individually, by putting together all the mistakes, we even them out and we actually get a better result. That is why now they're better than they've been in the past.
Thank you very much. Chair will now recognize the leader of the opposition for a speech not to exceed 7 minutes in length. Can you pull the desk back a little bit? Yeah, back toward the screen a little bit. Yeah, you're really, you guys are too tall. Yeah, thank you. Yeah, that's better. Thank you.
Hello everyone, my name is Steve.
Hi Steve.
And I'll be representing the opposition side, arguing that scientists using computer models are unable to accurately predict the future. Now the government side said they don't have to be completely accurate, and we agree with that. However, what we are disagreeing with is the average of how well they can accurately predict. According to Dr. Kevin Transberth, who is the head of the climate analysis section at the National Center for Atmospheric Research, the problem with climate model is they don't encompass a lot of the variables that are needed to predict the future. So variables such as the biological, physical, and chemical variables that do affect the weather, they are not highly represented. So he states this is just an oversimplification of reality. And he stated this back in 2007, so it's a little outdated. However, as of 2015, March of 2015, which is 2 months ago, Professor Clark, a meteorologist at the University of Reading, states that although we have made huge improvement in weather forecasting, it is still very complex, and a lot of the variables are still not understood by scientists. This leads to exaggerated and inaccurate results. So for example, according to both Vice President Al Gore and the IPCC, back in 2007, they stated that the glaciers in the Arctic were declining at a rapid rate such that by 2013, which was 2 years ago, there would be no ice left on there. However, according to NASA satellite in 2013, not only was the ice present, but it increased by 60% from its previous year of 2012. And this is not the only error by the IPCC. According to Dr. Patrick Michaels, director of the Cato Institute Center for the Study of Science, he revealed that in 2011, 18 different experiments were done, and they found that the IPCC's models were off by 46% in forecasting. Now, I'd like to clarify this. They weren't wrong 46% of the time. They were off by 46%. And these errors are just not made by the IPCC. According to former NASA scientist and current professor of the University of Alabama, Dr. Roy Spencer, since 1979 until the article he wrote, which is 2014, he conducted 90 different climate models that the government used or uses, and they were off by 95% when predicting, when forecasting. His quote, he says, "Government models have failed miserably." So we can see this is pretty 95% and 45%, 46% in accuracy are all very well, probably above average, and they are really not predicting very well. And one of the main reasons why they don't predict well is they don't account for all the variables, but we understand that they are unable to account for that. But the real problem is, of the variables that we do have, a lot of them are just not understand really well. According to Dr. Peter Clark, who is a meteorology professor at the University of Reading, as I stated before, we do not know the atmospheric condition is at one particular moment. So this fluctuation causes a lot of chaotic differences in occurrence. However, although we may not be able to see, calculate and see these unmeasurable variables, they still count and have a huge contribution to the end results, because even though if we don't see it, it's still there, as we all know. Although there are many variables that do influence the results, one of the big ones, as the government, I don't think they mentioned too much, are clouds. They stated that the El Nino and La Nina were a big contribution in helping predict future weathercasts. However, according to NASA, the main uncertainties, as Tice, my partner, mentioned, the main uncertainties in global change predictions come from the inadequate representation of clouds. NASA states the models do not have sophisticated enough descriptions of the cloud processing, and scientists do not have enough observation to verify these. So both scientists and the computer models are inadequate when coming to predicting these models. So why are the clouds very they are a huge factor? It's because their main focus is to warm and cool the Earth. So depending on the cloud and their levels, and there are different types of clouds which further really throws everything off. The clouds trap the heat that the surface emits, and also deflects a lot of the sun radiation that comes into the atmosphere. So they serve as both purposes. They block the heat and they also cool. But what scientists are having a problem with is two things. Number one, it's interaction with climate. The IESCCP stated that the clouds affect the weather, and in turn, the clouds affect the climate, and the climate in turn affects the clouds. So there's this constant feedback going on that scientists are not able to predict the net effect. And the net effect is basically how much goes in, how much goes out, and how much is retained. So they can't constantly predict this net effect that the clouds are showing. Clouds fluctuate very often, and we understand that. So the natural variations, and there are others, but for the sake of time, I cannot get into them. But there are a lot of variables that in the natural process that are pretty that disrupt the forecasting. However, nature is not the only thing that fluctuates. As we discussed in class, the emission of CO2. Now, how much it contributes, it's debatable, but we've all agreed that CO2 does affect climate change and weather. Dr. James McCarthy, chairman of the UCS Board of Directors and professor of biological oceanography at Harvard University, states that the fluctuation of the CO2 emission is the biggest uncertainty. CO2 uncertainty plays a significant role in predicting the future. We do not know how much carbon dioxide is going to be inputted this year versus next year, because it's dependent on human behavior and human activity. And we all know when it comes to predicting human behavior, we do not have a clue of how to do that. And in this, in return, affects CO2 and affects the climate, and so therefore it fluctuates too much, and we are unable to account for all of these. As I've mentioned, this causes a lot of disruption in predicting. As I've stated before, 95% of the government models were wrong, and Dr. Roy Spencer stated they have failed miserably. Also, as stated before, Dr. Michaels, he said 46% of them off, so we see that a lot of discrepancy is happening. Also, and on that note, thank you, and I will now stand for cross-examination.
Thank you very much. If you would come to the front of the podium for your cross-examination, not to exceed 3 minutes in length. Standing close to each other, please. Near the center. Good.
So we begin. So now you talk about Peter Clark at Reading, and you say that you quote him saying that this leads to exaggerated, inaccurate results. Now, I mean, this wasn't exactly cited, so I couldn't find the exact source you're looking at. But when I looked up this source, it seemed that he didn't actually say those exact words, did he? He said the portion before that.
No, I'm pretty sure he said inaccurate, exaggerated.
Well, actually, what he had shown is that there's only one example where there's one result he gave, which was the Bromswell Dam, basically destruction. And wasn't it true that that dam, he said, was destroyed because of a 5-degree uncertainty as a result of the wind change?
It was. I'm pretty sure it was somewhere around that, but I remember it was 1/10. He did mention 1/10 of the weather does determine whether there'll be flash floods or nothing. So.
Sure. Well, yes, but nonetheless, the point I'm trying to make was that if there was a 5-degree change in this instance caused by wind fluctuations, and now we can predict wind fluctuations, wouldn't that mean that now our models are significantly more accurate?
I agree the winds have gotten a lot better. However, they are dependent on clouds, and that is one thing that
You're persuading the audience.
Sorry,
Thank you.
they are not accurately represented, as we have seen with NASA. In turn, depending on how the wind goes, obviously hot wind, it goes up, down, and fast. It depends on how warm the temperature is, and that's where the clouds come in, and we really don't have an accurate. I know if you pointed out, you put it into smaller grids, it does provide a little more accuracy, but as we have seen with the percentages of the inaccurate models, they kind of...
Great. This is actually a great time to bring up clouds. So now you said that clouds are directly linked to climate, and that there's like a back and forth.
Mm-hmm.
But now that we can actually predict climate, don't you think that we're going to be able to really easily predict clouds? If that now we can, the one critical variable is now very easily predicted.
Right, but I would like to say, as I've stated, the climate is also dependent heavily on our actions, as I stated, the CO2 emissions. Now, how much of that is kind of iffy, but it still makes a contribution. So, so we don't really have an exact accurate on climate, and and also the atmospheric condition is kind of uncertain, so you only really have half the equation, so that's kind of inaccurate.
So move on to another thing. Do any of your sources actually use meta-analysis, or do you just look at the flaws in individual models?
I believe they use meta.
Right. I guess you could say the one from where they looked at 90 models from 1979.
Right.
Now, you said that there were 90 models from 1979 to today, and that 90% of them were 95% incorrect. Now, do you think that 90% of the models that were created from 1979 to 2005 could even run on the models in the operating system today?
Yes. Yeah. No, but my point of showing that was precisely to show that since 1979 and all the way to now, they still have not made the necessary technological advancements to.
Well, really I don't know if I could say that, because I think the only thing it showed was that that 95% of the models were inaccurate. Mm-hmm. Not that specifically the ones from today were inaccurate, just that the ones from 1979 to 2010 may have very well been inaccurate, but it doesn't mean that the ones today are inaccurate. Isn't that true?
I will have to say you have a very good point. However, in 2011, we did have a lot of the 18 researchers, and all 18 were off by 46%, so that's...
Okay, thank you. Chair will now hear from the member of the government for a speech not to exceed 7 minutes in length. Can you pull that table back that way? Yeah, come back toward the screen. Yeah, good. Thank you.
Hi, so I just want to start off by giving you guys a little quote. Now, I won't go into too much detail about what the quote means at the moment, but I just want all of you guys to keep this quote in mind as we move throughout the debate. So the quote is by a statistician named George Box. And what Box said is this: all models are wrong, but some models are useful. Now, there's been a lot of skepticism and cynicism when it comes to statistical models. Critics of these models, such as my opponents, will say, well, we don't have enough information to be able to make accurate predictions, or, well, models can't realistically depict every aspect of the world. And these were all cases made in particular by Bjorn Lomborg in his 2001 book, The Skeptical Environmentalist, as to why we shouldn't trust models. Lomborg states, and I quote, basically, we have to conclude that the present models are complicated, but far from complicated enough to capture all the essential aspects of global climate. In other words, current models are too simple, according to Lomborg. Now, I do not disagree with Lomborg's statement. What I do disagree with is the conjecture that 1, a simple model necessarily equates to an inaccurate model, and 2, a lack of information necessarily equates to a lack of reliability and certainty in forecasts. In fact, a 2009 study in the International Journal of Forecasting by researcher Keston Green, Scott Armstrong, and Willie Soon found that even using a much more simplified model than those normally used still allowed them to produce accurate forecasts. And it turns out, actually, that their simplified models were able to produce even more accurate forecasts than the IPCC's model. The errors produced by their forecasts were about 1/7 of the errors produced by the IPCC model, and the relative accuracy of their model actually increased at longer time horizon. A more recent 2012 study by Mark Mazin and Patrick Austin also found that as models try to incorporate more information, as they try to become more realistic and complex in their depiction of climate processes, the models actually became less accurate and predictive. According to Mazin and Austin, complex models are actually more likely to produce wider rather than smaller ranges of uncertainty. So if adding more realism and more complexity leads to less accuracy in forecasts, then one can't say that a lack of realism or a lack of complexity will automatically lead to inaccuracy in forecasts as well. Now, I want you guys all to think back to the quote I gave you at the beginning. All models are wrong, but some models are useful. Now, what George Box meant by this was that models, by their very definition, are just representations, just approximation of reality, and it can never hope to fully capture all the complexity of the real world. But even so, thus to some extent, models will always be wrong. But even so, using models, even a simplified model, is still a good way for scientists to test their theories about the world and to make accurate forecasts. So we should focus less on whether models can be wrong and more on the fact whether models are always wrong. And we should focus less on what models lack, like, oh, they don't have enough info on the clouds. Oh, they don't have enough info on the water vapor system. But rather, we should focus on the wealth of information that models do have. We don't judge how rich a person is based on what they don't have, but we judge them based on the multitude of things they do have. And we don't judge intelligence based on what a person doesn't know, but rather on the significance of things they do know. So what do models have or know? Well, models have the capacity to be able to reproduce the seasonal variation of Arctic sea ice to a mean error of less than 10% for any given month, according to the IPCC's 2013 Fifth Assessment Report. And according to that same report, models have the capacity to reproduce important seasonal variation from the North Atlantic Oscillation, the El Nino-La Nina cycle, the Indian Ocean dipole, and the quasi-biennial oscillation. And through a method called downscaling, they have the ability to accurately simulate things such as monsoon precipitation pattern, Atlantic hurricanes, mesocell cyclone, convective precipitation, and more, allowing them to predict regional surface temperature with an average error of near 0. And models know enough that they are able to reproduce a large-scale precipitation pattern to a pattern correlation of 0.82 with the actual observed value. And models know enough that they are able to predict large-scale global temperature to within a hundredth of a degree of the actual value, as proven by a 2013 study done by Miles Allen at Oxford University. And models know enough that they were able to successfully predict the 5 degrees Celsius in global cooling that occurred as a result of the eruption of Mount Pinatubo in 1991, as shown by a 2007 study by James Hansen of Columbia University. And models know enough that they were able to accurately predict the expansion of tropical atmospheric circulation pattern known as the Hadley cell, as well as the increase in coastal upwelling of ocean water, according to a 2006 study by Fu et al. And 2007 study by McGregor et al. And it can certainly go on listing all the instances in which models have been right, but that would require more than 7 minutes that's been allotted to me. The fact of the matter is The fact of the matter is that models are so good at what they do that according to the OSF organization, scientists actually use them to identify measurement error in the real world. Because oftentimes these models are more accurate than the instruments actually used to measure the true observed value. For instance, a 2004 study by Stephen Sherwood of Yale University and a 2005 study by Ben Center from the Livermore National Lab found that the predicted trend produced by models did not match with the satellite data of the observed value. The models predicted an upward trend, while the satellite data showed that temperature remained relatively stable since the 1970s. And the reason for this discrepancy, it turns out, not because the models were wrong, but because the satellites were not calibrated correctly. So, to give a quick sum up, because I'm running low on time, we should not, models are more efficient than they are deficient. So models are more efficient than they are deficient. So we should not let the overblown doubts from my opponents prevent us from using these models, because perfection is not necessary and complete realism is not necessary. The preponderance of facts show that these models are able to accurately predict future climate events. I now stand for questioning.
Okay, if you could come to the front of the podium, please, for your 3 minutes of cross-examination, I'd be most grateful. Standing close together, near the center. Good.
So you mentioned the simple models are better than complex ones. However, according to Dr. Spencer, only 1 to 2% cloud error makes the difference between global warming and global cooling. So do you think that simple ones are better to use than complex ones when the margin of error is so small?
Well, I didn't say that simple models are better than complex ones. I say that you don't. What I'm trying to say is that you don't need a complex model that incorporates every variable of the world in order for it to be accurate. Because even a simple model, as the one used by Keston, Green, Scott, Armstrong, and Willie Soon, found that even with that simple model, they can still produce accurate forecasts. So I'm not saying that simple models should be used in replace of complex model. I'm just saying that you need to have all the complexity of variables is like not true.
So you're saying complex models are required and they should be for forecasting?
I'm not saying they're required. I'm not saying that just because they're not complex, you can't use like they're not accurate.
Yeah, so you're agreeing that complex models are required, are needed to forecast.
They're
along with the simple models.
Yeah, you should need both.
Okay. You say the lack of information regarding the environmental process does not warrant dismissal of using models to forecast climate events. I agree with that. However, do you think that these environmental processes that we do not have a firm understanding of have an impact on results?
Yes, like for instance, the cloud that you mentioned, they do have an impact on climate, and they are a point of uncertainty. But then there are a lot of variables that we are uncertain about. The point is that we have come to the point where we are able to minimize it enough that we are able to make accurate forecasts. Okay.
Yes, there's no doubt that today's models are more adept in capturing variables that the previous do not. However, do you agree that of the variables we are capturing, they are still either inaccurate, a lot of the representations, and they are not properly understood?
No, because the studies that I've listed show that models can be very accurate, even though they are missing or they don't have a full understanding of some of these variables. So my studies show that the opposite.
However, as you mentioned, a lot of your studies were pretty accurate, but as of 2011 and possibly close to 2014 from Dr. Spencer, 95% of them were wrong. I'll give you that, the previous ones were probably included, but as of recent of 2011, which is pretty recent, still all 18, which is 100% of the models were off by 46%. Do you agree they're still pretty accurate?
Yes, because as Austin said, the individual models by themselves were inaccurate, but we can average all the results together and still produce a good, accurate result.
As of today?
Yeah, we can average model results today.
Okay, you say small errors can accumulate very quickly in complex models. Do you agree that these accumulated ones... Oh wait, you say small errors can accumulate very quickly, that's correct?
I didn't mention that in my speech.
In your brief, you did.
Yeah.
So, Dr. Clark mentioned occurrence.
Okay, that's time. Thank you.
Thank you.
Okay. It's now time to hear from the member of the opposition for a speech not to exceed 7 minutes in length.
Are you getting the right picture?
I'm trying, yeah. You're a tall fella.
Back up a little.
Yeah, back up a little.
A little lower.
No, just back up toward the... Yeah, pull the desk back toward the... There you go.
Or you want to check this out in the video?
Okay, we're good now.
Alright. We are discussing something quite complicated today, so I want to break it down into two simple parts for you. First of all, I want to look at previous predictions and see if they are right, as I do believe they are relevant to this debate. And second of all, I want to explain why, as we will find soon, these predictions weren't accurate. So, by simply looking at these predictions and seeing if they were correct, we can establish, without any reasoning, if they are accurate. And we're not saying that climate change isn't happening. We're simply saying that the models that are being used to predict climate change are not incorrect. An example is the melting of the ice cap in the Antarctic. A group of European scientists from the universities of Bristol in England and Utrecht showed that the ice in the South Pole was melting at a far faster speed than what they had predicted previously. The predictions for the increase in temperatures in the air and sea that led to melting these ice caps were clearly off. Another example of inaccuracy in the prediction of future climate events can be found in the predictions of weather events such as tornadoes. Similar to making predictions in economy, where a single isolated event can lead to changing a course of the prediction, weather events such as tornadoes are relevant, and they are notoriously unpredictable. A study of the University of Texas in 2013 showed that prediction of tornadoes were so unpredictable because scientists do not have enough computer capacity, first of all, and second of all, are unable to monitor all the relevant data. They are in fact so chronically inaccurate that the public does not take these warnings seriously enough, as I have stated in my cross-examination. Now, we have established, based on previous predictions, that these predictions are inaccurate. Now I will get into why they are inaccurate. And first of all, variables that we do not understand play a role in this. An example is the way the formation of clouds influence the temperature on Earth. In a long and extensive research project formed by a team of scientists from the United States and Korea in 2013, gives an example of this mechanism. When sea temperature rises, water vaporizes, creating more clouds, which then reflect the sun rays coming on the Earth and make sure that even though sun previously warmed the sea, because it warmed it so much, it's now cooling off the Earth again. This is called negative feedback. Another example of this negative feedback can be found in a research by the Canadian Meteorological Service in 2013. It showed that forest fires, often caused by climate change and increase in temperatures, change the surface of the forests. Whereas previously these surfaces were dark because of the trees, the forest fires have created lighter woodlands, that appear after the fire, and these lighter woodlands reflect the sun rays back into the sky. This is another example of negative feedback, which cannot be accounted for in computer models. Another argument for why climate change predictions using computer models are inaccurate is because they are paired with computer capacity. Climate change and weather events prediction is immensely complicated and relies on a wide variety of different variables. Computing power used and necessary for calculating these models must not therefore be very high, and as of this date, computers are simply not powerful enough to adequately perform these calculations. An example of this is a study done by the University of Oxford in 2014 and published in a Journal of Computational Sciences. It investigated the use of computers in climate change models. And they found that scientists use hardware that is not good enough to adequately predict. They do this because the use of this hardware allows for them to make the calculations quicker. However, this comes at a cost, a decrease in accuracy. Therefore, scientists admit that the models they use and the hardware they use for predicting climate events is inaccurate, but they have to, because they need to make these calculations somewhat feasible and within a certain time range. So, as of today, the computers used for these computer models are not powerful enough to adequately predict climate changes. To sum up this argument, climate change models are not accurate because they do not have enough power. Another argument is the fact that certain initial conditions are uncertain. A concern with mathematical models to predict climate events is the fact that initial conditions on which these models and calculations are based are often uncertain. An example is the amount of CO2 gases in the air, or the amount of cars emitting such gases, or the amount of trees that take in such gases. These are all simple examples, and they are impossible to accurately enter into the calculation, which means that at the end, with the initial conditions uncertain, the outcome is also uncertain and accurate. Research by scientists associated with the National Center for Atmospheric Research in the United States and the European Center for Scientific Calculation in France has shown that this initial condition uncertainty poses serious challenges for those trying to predict future climate events using computer models. They found that the dominant source of uncertainty is the fluctuating variables of certain chemicals in the atmosphere. This makes it very hard to set an initial condition for these models, and thus to predict changes of these chemicals in the future. They estimated that this initial condition uncertainty accounts for nearly half of all what they call intermodal spread, meaning the different outcomes in all the different computer models used. In short, based on the data we have provided, we have shown that previous predictions were incorrect, and this is because computer models might be able to give an estimation, but due to the limits of these computers performing these calculations and the fact that variables upon which they rely are constantly changing and uncertain, they will not be able to accurately predict climate events. And I now stand for cross-examination.
Thank you so much. You come to the front of the podium for cross-examination not to exceed 3 minutes in length. Stand together. Face the audience as you ask and answer your questions. Thank you.
So, in your presentation, you discussed a study done by the Journal of Computational Science about the hardware using climate models, correct?
Yes, that's correct.
And you stated that these hardwares used by climate models have faults in them, correct?
Well, they don't necessarily have faults in them. They are simply not good enough to adequately perform these calculations because these calculations are so complex. They must use hardware that make them quicker, but also less accurate.
Oh, but in the actual study, it says that they were studying hardware-induced faults in climate models. So then the hardware would have faults in them, correct?
The hardware they use create faults.
Talk to the audience.
The hardware they use in these computers create faults in the outcome of the predictions because they have to use hardware that is not as accurate because otherwise the calculations cannot be done.
Okay. So just to make clear to the audience, all your study proves is that there are faults in the computer, but not faults in the forecast themselves, right?
Well, I think it's fairly, it stands, how should I put this? It's not too hard to understand that when the hardware you use to make the calculations is not able to adequately predict these outcomes, the outcome themselves is probably not going to be as accurate as could be.
Really, because that's contrary to what your study actually proves. I have a quote from your study. It says, stochastic processors allow hardware-induced faults in calculation. So you're right, there are faults in the computer. But then it goes on to say that by allowing for these faults, you are sacrificing bit reproducibility and precision in exchange for improvement in performance and accuracy of forecast. So doesn't this actually prove my point that even if models are not perfect, even if they have faults even in their hardware, they can still produce accurate forecasts?
Well, I would like to focus on what you said, which is the part that you sacrifice precision in these calculations. You have to sacrifice this precision because otherwise the calculations cannot be done. And if you sacrifice precision, combined with the fact that initial conditions used for these calculations are often, first of all, uncertain, and second of all, changing and fluctual, the outcome will not be as accurate as could be.
But they proved that the outcomes were accurate in the study. And all they showed was that even if the hardware had problems in it, the outcome were, the forecasts themselves were okay, or actually they could even be improved. So isn't that what is contrary to what you're saying?
No, I don't think that's contrary, because we have shown that previous predictions using these hardware were off. So
but the study you cited proved that
Can I finish my answer? So the predictions using this hardware were off. So perhaps...
That's time. Thank you. It's now time for those famous 4 steps of refutation. So let's hope we see them. Let's hear the leader of the opposition for a speech not to exceed 5 minutes in length.
Okay, so everyone, I'm Steve again.
Hi, Steve.
I'd like to point out, now the government brings up a good point that these models are our best bet, and we agree with that. However, we do not agree that they are very accurate on average. They said they could accurately predict the future and forecast. I disagree because as shown in the past, many of the models were not able to capture all the variables, and even in recent ones such as 2011, as I mentioned, they're still unable to accurately predict the models. 46% off, not 46% wrong. So all of them were off by 46%, which is a large margin past the 20% error that they stated in their definition. They said by not accounting for all the math is okay. I disagree, because as Dr. Clark stated, the difference and occurrence of the unmeasurable variables can have a huge impact. Dr. Spencer mentioned that only 1 to 2% in error in the clouds make the difference between global warming and global cooling. So with that very small margin of error, the not accounting for all the math is really a big problem and can make a big inaccuracy. Therefore, not accounting for all the variables causes inaccuracy. They say climate models are powerful statistic tools. They can be reliable to use to produce accurate forecasts. I agree that they can. They will use to predict accurate forecasts. I agree they can, but I disagree that they can, as of now, produce accurate results. As I keep mentioning, Dr. Spencer and Dr. Michael showed how inaccurate the IPCC were and how flawed the models were, and as recent as still till now. One thing they pointed out, they said dramatic increases in technology has enabled scientists to accurately predict results fairly on average. I disagree, because as NASA stated, clouds are still a very mystery to us, and we do not know how they form or function, and scientists still do not have enough observational skills to accurately verify these models. Therefore, increase in technology has not enabled scientists to accurately predict the future. They say when looking at the big picture, many of the erratic variables cancel each other out, such as the El Nino and La Nina. I disagree because according to Anthony Farnell, the IPCC overestimated temperature rises, as they have mentioned. They fail to capture the cooling periods, which are actually influenced by these erratic variables. So they did not cancel these variables out, indicating that they have a huge impact. Therefore, these erratic variables do not cancel each other out as time progresses. And if you look at the big picture, which was around 10 years in our definition. In their brief, they said clouds do not matter. I disagree. As I stated, the ISCCP, the International Satellite Climate Change, clouds are responsible for warming and cooling the Earth. Now, this is a big function of just one variable. I've also mentioned that it only needs to 2% error to cause a complete change in the outcome. So anytime there's a variable that has less than 5% error, change should matter, and that's what clouds are. Therefore, clouds do matter. And I would like to close by one saying that the government said that the models are our best bet, and this is not where our disagreement is. However, our disagreement is the accuracy at how accurate they are in predicting the forecast, and I have proven and shown that a lot of their models, sometimes even most, are very inaccurate. Therefore, I hope that you would vote for the opposition. Thank you.
Thank you. Chair will now recognize the leader of the government for a 4-step refutational rebuttal.
I want to open with noting something that the Speaker Theis brought up in the beginning of the speech. Now, we said that this is a complex issue, so we should break it down to simple terms. Now, we're saying this is exactly how we deal with complex issues, by breaking it down to something simple. We don't just take everything as it is, as they say we need to do with climate models. What we do is we take something complex, we make it simple, and we make it as simple as possible that still gives us accurate results. And that is what we are saying we should do on the affirmative side. Now, we want to start off by going through some direct refutation. Now, first they say we don't take into the account a lot of the variables. And we say that there's really no impact to this. So what? Yes, we don't take into account some variables, but we have shown empirically, not just through testimony of apparent authority figures, there are empirical examples how we've actually increased, something I'll go more into later. They additionally say that government models have been counted time and time again inaccurate. And we say, okay, fine, because science examples of people from universities have been very accurate with the new statistics we brought up multiple times. And that is why we disagree with that statement. Now, one of the major points they bring is they continually say that clouds are the most important thing, and they go on to strawman us, saying that we say that they're not important at all. And what we disagree with that is because we say they're important. We just say they're not necessary. There's a very big difference there, and yes, they may be a big issue, but that doesn't mean that they are the absolutely crucial to making a critical climate decision goal. And that's something you need to take into account. Additionally, we said that George Mathis from JPL has actually been able to make great leaps, and when they brought up the idea that climate affects it, we've shown that, well, if climate is the thing that's majorly affecting it because it's in this feedback loop, and now we can predict climate, we can now more accurately predict the feedback loop. It's just basic logic. Additionally, they also gave us another strawman where they say that all of our, we said that El Nino cancels out. And what we want to point out here is this is not at all the case. El Nino does not cancel out. What we were trying to show you with the James Ribsey et al. Article from Nature of 2014 is that we can now look at these El Ninos and we know exactly how to predict. We predicted the trend by, retroactively, of course, I guess I didn't say that, by looking at El Nino statistics. And additionally, the other articles we brought up have actually shown you how we can predict El Ninos. Now, the final thing, they say that tornadoes are basically this huge issue. And now, we disagree with this because we say that fundamentally tornadoes are a different system. Because what you see is that tornadoes are a result of turbulent flow. And this is another one of the millennium problems, where no one can predict turbulent flow. It's a very rare occasion. It's not like all mathematically. Turbulent flow is actually what Terence Tao is currently working on at UCLA. It is not the general norm with these climate predictions. And it's not fair to say that just because they cannot accurately predict tornadoes, that they cannot predict everything else. It's a very rare case. And because of that, we disagree. We believe that that grants no adherence in this debate. Now, what we want to move on is to what we have brought you in the debate. What we've shown is that we've brought in a two-pronged approach to this side. What we've seen from Cao Cao's speech is that we have given you multiple empirical examples of how actually our models have been correct, which I will cite directly later on. But additionally to that, when I come up and speak, I said that even if you do not grant adherence to the multiple of examples that we've brought up, by using meta-analysis, we can take flawed models and make them correct. And that is where we go into basically what I feel to be the two major issues of the round. The first being simplicity versus complexity, and the second being models versus predictions. Now when we look at simplicity versus complexity, we basically look at, does simplicity equals a flawed model? And now we're saying that yes, there will always be some flaws, but we do not necessarily believe that simplicity equals a wrong model. And basically we look at this from two aspects, not just by looking at what people say. We look at one, theoretical math. By looking at empirical results of theoretical math, can you get proper results from another system that's not necessarily climate change? With this, we look at the Navier-Stokes equation, where we have shown you that that we actually can get something from a simplistic system where you don't understand every variable. The second of which, we looked at the empirical examples in climate change. We show IPC in 2013 can predict seasonal ice changes up to 10% accuracy. We've shown that the Oxford professor Allen in 2013 said that we can show up to a 100% of a degree the temperature change from 1916. We've shown you time and time again with empirical examples that we actually can. But even if you don't buy these, we look at the second issue of this debate, models versus predictions. What you see is that even though you have a flawed model, we make accurate predictions. Now they've shown you no meta-analyses of models to actually show this. All they've shown you was that from 1979, they looked at 90 software models, and that 95% of them predicted wrong. That doesn't mean anything. As Tice even said, that there are hardware limitations throughout time. Now though, we have accurate models. We've shown you from Jane Ribsey, Matt England, and Yuko Saka, that what we can do now is we have meta-analysis that let us take even the flawed models and make them give us accurate predictions. For those reasons, we strongly urge an affirmative ballot. Thank you.
Thank you very much. You may cross the house and show your good sportsmanship by shaking each other's hands. It's now time for the judges to do their job and to confer individually, Amanda, and decide for themselves how they're going to vote. Thank you. Do you have either cross-X or more...
He left this year collecting.
you have cross-X questions or something to give me?
I'm sorry, I didn't have time to type them up.
Thank you.
Can you pass this in if you want? Professor?
Are there any more ballots?
Yeah.
Thank you.
Oh, wait. The last page is not yours. I see.
Any more ballots? Somebody have a stapler?
I do. I got your stapler. You lost it.
Professor, I have one if you need it.
He was looking for it now. I used to like
Okay. You ready? We'll start in the rear back there in a 23-0 decision. It goes to the government. This is our first shutout of the season. So let us hear why and see if we can find some understanding to this decision. Yes, please.
Hi, my name's Colleen.
Hi, Colleen.
So I voted for the government. I just thought. Sorry. I just thought Austin and Tao spoke really confidently, and they really showed like they knew what they were saying. You know, and I think that confidence from the get-go really like drawed me in, and then because I was so into what they were saying, I was waiting for like legit like poking holes, and whenever I felt like the opposition did that, the government during cross would like, and then during the rebuttal kind of brought me back to them because they really refuted really well. But I think the biggest thing is that they just spoke more confidently, and I don't know if they had it memorized or whatever, but they were really like looking at the audience and engaging with the audience. So
Okay.
I voted for government.
Okay, thank you. Yes, please.
Hi, I'm Garrett.
Hi, Garrett.
So I too voted for the government, but I might revoke my vote just to give you guys a little bit of pity on the side. Hey.
Don't do that, that just makes it worse.
No, but okay, fine, I'll name some good things. To start off with, Austin, you're very strong character up there. Tal, I was pleasantly surprised with you. I did not expect you to be out so like forceful, but I really like that. And then also, you said, what was it? Everything you said had a source behind it. And you had it like almost in the back of your head. You pulled it out like Columbia, Harvard, this source. It was good. That's mainly why I went with you guys. You guys had a great presentation. You guys did very good as well. You guys did. I liked your questioning better than theirs. I mean, they were very condemning, and after a while I was kind of like tuned out because it was always condemning. So kind of tuned out. But you guys very calm, and Steve, you handled really well with being questioned. I mean, he's intimidating. He was like, you testified earlier. And I was like, whoa. And then he's like, no. And he came with like a very scientific thing. He responded back, like right back at him with 1/10 of, I don't know what you guys are talking about, but I was like, right on, right on. And of course,
zoom in.
I'm ready for my close-up, Mr. DeMille. I'll be done soon. And then lastly, I thought you did a really good job too. You're very calm, like very. I didn't think you were nervous up there at all. So very good job.
Isn't that?
It's Daniel. It's fine. Just leave it the way it is.
Okay, my name is Hussein.
Hi, Hussein.
So the reason I granted adherence to the government, I think overall you guys just seemed a little more in tune with your material. It's not due to a lack of preparation or anything, but I mean, Austin, I think with your experience, you were really coherent. It was really easy to follow. You told me like 10 times to grant adherence to you, so I did. Tao, I don't think you looked at your paper for more than like 2 seconds. I think at one point you were looking away from it for like 15 seconds. I don't know if you were like spitballing or what, but that was really impressive.
Yeah, I mean every statistic.
Yeah, I believe it. No, I wouldn't know. No, but really, you guys are convincing.
You might want to change your vote now.
Yeah, and I just want to say that I granted adherence to the government because of a stellar performance, not because of lack of one from you guys. I thought you guys were very adequately prepared, and against another team, you might have won, but I thought it was an overall really good performance.
Yes, please.
Hi, I'm Amanda.
Hi, Amanda.
I actually wanted to say that I don't think the results reflected how close the debate was. I think you guys all did a really great job of presenting your information. All of you guys were pretty extemporaneous. I feel like the four of you guys looked less at your paper than any other group did. I just think that overall it might have been a little bit more dynamic, might have had a little bit more of their sources lining up and stuff like that, but for me it was just a little bit, so I think you guys all did a good job.
Okay, good. Thank you.
Hi, I'm Lexi.
Hi, Lexi.
I would also like to argue that you guys were all really, really great speakers. I don't think I was worried that any of you were reading your paper at any point. I voted for the government, I think, just because of overall performance, and especially at the end with the rebuttals. Austin, yours just kind of trumped Stevens, but I think you guys all did a really great job.
Okay, thank you. Yes,
Hi, I'm Aubrey.
Hi, Aubrey.
I granted adherence to the government side, and I don't mean to be redundant, but I felt the same way. I felt both sides were really strong. I had a number 1 and a number 2 speaker from both sides, but yeah, everyone did a really great job, and everyone provided great evidence. I was definitely going back and forth between the two, but they also said, the presentation side of government was just really spot on as a team, so good job, you guys.
Sure, yes, please.
Hi, I'm Natasha.
Hi, Natasha.
Hi. Personally, Austin and Tao, you did a great job with your debate structure. Austin, the fact that you brought up 4 different elements that would debunk all of their arguments, automatically it just ruined the whole presentation from the get-go. It's like they built up this huge tower and you just ruined it, disbanded it at the very get-go. So I really enjoyed that. That's why I granted more adherence. Also, I appreciate the analogy of the coin. That was a good analogy. Tao, your quote really lingered with me. All models are wrong, but some models are useful. And I really like the part where you said models are useful because of their predictions, and the equipment used to predict their errors are not necessarily accurate or correct themselves. So I thought you tied that back in really logically and soundly. And then also, Austin, your refutation was great because you pointed out all the fallacies, which really actually made me grant even more adherence to you guys. And Steve and Tice, I think you guys did a great job again with preparing. I think all of your arguments would have been great if they weren't already, debunked from the get-go. So great job to all of you. Great preparation.
Okay. Thank you.
Yes, hello, I'm Mackenzie.
Hi, Mackenzie.
I thought this was a really great debate. Everyone's kind of said that. I think individually everyone did a really great job. I thought this was one of the best debates as far as everyone speaking and connecting with the audience. Like Natasha said, I think Austin just did a really great job at the beginning, compelling us all to side with him. And you guys had fantastic sources. You had really great points that you were trying to assert. But it was just, for me, a little too subdued. I wish you guys had a little more firepower in what you were saying. It was very methodical, and you guys went through point by point very clearly. But it was hard when you have Tao charming us all and making us laugh, and Austin using his hands and getting us involved. So it was close, and good job. Everyone did a great job.
Yes, please.
Hi, I'm Miranda.
Hi, Miranda.
Going off of what Mackenzie said, I almost did give it to the opposition because I was almost a little overwhelmed by the government. While I thought being dynamic was really important, I almost felt like you guys were coming on a little too strong on a lot of it. But overall, I think that your argument was better supported and stronger. So I ultimately had to go with that, and of course you guys were great, but I really do like that you guys took a very calm, you remained calm during your cross and everything, and I really, really enjoyed that. I found myself paying more attention to what you were saying, and then other times I did feel a little overwhelmed, but they just got you on a better overall presentation.
Hi, I'm Laura.
Hi, Laura.
I voted for the government. In regards to any sort of delivery, I think what's already been said for both sides, but in regards to that, did pretty well. But in regards to content, I think for me, it just absolutely had to go to the government. I think that the opposition did not address a lot of what the government was arguing, and they argued a lot of things. They tried to argue a lot of things that the government agreed with. You know, talking about clouds or whatever, and I mean, Austin even pointed that out in his speech, saying we're not saying it's not important. We do, you know, agree with this, and I think there was just like this mismatch. Also, I think the opposition kept going back to the same sources, and like, okay, well, if that source got debunked, okay, well then how are you gonna, you know? I also didn't see the connection. So the government argued a lot about, you know, the computer models may have faults, but that doesn't necessarily mean that they're not accurate in predictions. I would have liked to see some sort of drawing connections from the opposition to, you know, disproving that, and there was no effort on that. And then there was also, in regards to, they had a really interesting, you know, pulling the meta-analysis of all of the models together can create an accurate prediction, and you just handled it very singularly. From the sources, and I would have appreciated, you know, maybe that's probably pretty hard to do, but you know, seeing if there's a way to kind of find a way to get around that and address that point a little bit better.
I appreciate you focusing on the content, because we've all been pretty much saying the same thing about delivery, and I'm glad we're focusing more on different items. If we can do that for the rest of the comments, focus on new things, that would be great. Yes, please.
Okay, hi, I'm Sam.
Hi, Sam.
I also voted for the government, but kind of similar to Miranda, it was close. Actually, I was also a little overwhelmed. Austin, I thought you spoke really fast at the beginning, so it was hard for me to follow. But Tao, I thought you did a really good job of bringing it back in. I have on my sheet that you mentioned like an 82.82 correlation, which like I took stats, so I happen to know what that means, and that like stuck out to me. And that also, I really like the satellite example where you were like, the satellites were wrong, our models were right. That was kind of close to the end, and I was like, wow, like, okay, the satellites are wrong, but the models were right. For the opposition, I thought you guys could have crossed them harder. Like, I feel like there was a lot of points that they mentioned. They were like, oh, they're going to tell you this, this, and this, and then, like, well, not like, it wasn't super backed up. Like, you could have taken them down, but because like I didn't really hear a response, I wasn't sure, so I just believed them. I liked that you guys clarified the difference between the % off and the % wrong. I thought like you made that very clear, and like otherwise I would have thought it was % wrong. So that was nice, and I also thought you guys spoke at really good paces, which was easy to follow, and I understood where you were going. So good job.
Yes, please.
Okay. Hi, I'm Elliot.
Hi, Elliot.
I think that you two did a good job in your delivery. You guys were speaking clearly. I think you could have been a little bit more dynamic. Both of you probably could have been a little bit more dynamic. But I think that you spoke clearly and slowly, and that was easy to understand, because at times you were a little bit hard to follow, Austin, even though you spoke and did incredibly. I think that you guys could have used stronger evidence to show why models, like what models didn't work. And you guys just could have used more passion and talk, like everyone has said this, but you guys had a lot of like passion and authority, and you guys were very well researched, and that just helped your case overall. Where you guys, if you had better evidence supporting what models were wrong, that were huge and a big deal, and why it matters that those models are wrong, because there wasn't a lot of discussion on like why it matters. I don't know, I think I would have wanted to see a little bit more of that. You guys both held your own when you were receiving the cross-examinations, even though theirs were pretty strong, so that was good. You guys were calm the entire time, which was impressive. The 47% thing was great. Let's see. Your refutation was a little bit dry. His just like killed it. Obviously, Austin's was really great. Let's see. I really appreciated that you used logic in your argument as well, not just evidence. I think that was a big deal because I think that that was something that lacked from the debate overall that I would have liked to see a little bit more in. Yeah, I think, oh, and I really like how you, I know this is mentioned before, but in the very beginning you addressed all of the claims that could have been made against you and you directly attacked them immediately, so you, because of that, had everyone on your side off the bat, which was just a very great advantage that you took advantage of. Okay, there we go.
Thank you, Elliot. Yes, please.
As everyone said, it was really tough. Oh, Sarah, sorry.
Hi, Sarah.
Yeah, really tough. You all did a great job. All spoke really extemporaneously. I think for me, the decision came down to the criteria. Austin emphasized it was about the quality of evidence, and I think they just had better, more credible, more well explained, bit more like logical arguments. But you did fantastically. As Elliot just said, you held your own cross really, really well, and you all seemed super researched. So that was great.
Yes, please.
Hey, I'm Yasmin.
Hi, Yasmin.
Obviously, you know who I voted for. Austin, you obviously have like a lot of credibility, and like when you spoke, like people listened. But you came in and you set the bar really high, and I thought the opposition actually really stepped up. I thought you guys did really well and like really put up like a really good fight. I voted for the government, just like in a statement, what I wrote in the ballot or whatever. I voted for you guys because of the overwhelming relevant evidence that you guys provided. Overwhelming really was highlighted with Tal. You were going on about like the model was right in this case, this case, this case, this case, and you said, and it can go on, but I'll exceed the 7 minutes. I was like, oh, okay, that's all. I thought that was really great. And then Austin, you really highlighted relevant in your closing statement. You brought up like, I think it was the tornadoes that you were talking about, how like you just like completely shattered that argument that they had and just said, and because it's so relevant, I don't think you should grant adherence to like any of the evidence that the opposition provided relevant to that topic. So, yeah, kind of like Sarah and like most people, just your guys' evidence, and it was really good.
Okay, thank you. Yes, please.
Hi, I'm Stephanie.
Hi, Stephanie.
I voted for government, and I think mostly because of Tao's speech. I thought you did the best. It wasn't so much just the quality of the evidence, because everyone had good quality evidence, but you connected it all so well. Like, it was just really great job. You had the logic there, you had the evidence there, but yeah, you didn't just spout out evidence, you really logically connected everything up. So it was really great.
Thank you. Yes, please.
Hi, I'm Jasmine.
Hi, Jasmine.
I voted for the government. Like a lot of people already said, it was just a really close argument because I actually thought like the opposition was, they were really good speakers, and I really liked the pace that they spoke at because it did make their arguments more understandable and easy to follow. And I really liked that about them. But like in fact debates for me, I find that oftentimes it can just seem like a game of he said, she said.
Yeah.
So I go off of like the trustworthiness of the speaker. And I think they presented themselves a little bit more expert, the government, when they were speaking, and so that's something why I decided to go with the government.
You make an important point about fact debates, but that's often what happens in them. Yes. Yes, please.
Hi, my name's Ariella, and like everyone else, I voted for the government. Something that you guys did that I really liked was that you had like these sound bites. It's really easy to like stop paying attention, and as the debate goes on, like you're kind of tuning out, and then you guys would say something that would like stick in my head, like more efficient than deficient. And that like sticks in your head even when you're like not fully paying attention, and I thought that was a really, really strong tactic. But something that you guys did that kind of lost credibility in my eyes is that you were talking while they were talking, and I don't mean to be obnoxious, but I feel like if you guys were like listening to them more, that would have like looked a little bit better. Like you could have passed sticky notes, which is what a couple other teams did, and I thought that was really good. And I liked that you guys were working together because it's obviously really important. But I just think it looks better if you're not talking while the other team's talking. Sorry.
That's a good point.
Something that you guys did, I think that, Tice, you have a good potential to actually be like a politician, just because like it's really easy to feel really calm when you're talking. Like you're laying out these facts and you have like a certain air of confidence behind them, and like it's like, okay, keep talking, like I'm gonna keep listening. If you had been a little bit fiery, I think for both of you it would have been an even closer debate. In the end it did come down to their being dynamic, so good job to both of you.
Interesting. Yeah.
Hi, I'm Niaz.
Hi, Niaz.
Hi. Yeah, just like everyone said, I thought that this performance was really well, and you guys actually, you guys all looked up and you really elaborated on everything. So I thought that the fact that you guys were elaborating, it made you guys look really credible, all of you guys. But I just thought the government, there were more techniques that really stuck in your head, like how Tao emphasized that models know enough, and you would keep repeating models know enough, and then you would say what they know, and you kept repeating it, and then actually, like, I don't know, I was listening, and I actually noticed it. And then the opposition did prove that climate models are not very accurate, but you guys like proved that in general they are accurate. So I just thought your evidence was more compelling because like, in general it's more accurate, and yeah, you guys are more aggressive in putting your points across. So I just thought it was more effective.
Hi, my name is Gayana.
Hi, Gayana.
Okay, so I liked how the government outlined the arguments for and against in the beginning. I thought that really centered me around your side, even from the get-go, like Natasha said and some other people. I like that you guys said convincing vision. It really helped me because the arguments, I think, were pretty good on both sides. I think that kind of drew me into you, especially towards the rebuttal. I also like that you guys had logical, like almost impressive arguments. You connected the evidence to the logic back to the point a little bit better than the opposition might have. I also like the idea of the meta-analysis, pointing out that it's models versus predictions, I think you said, and considering we're debating if the predictions are accurate and not necessarily the models. I kind of liked how that worked out. And you guys could have rebutted a lot of what they were saying, but I feel like a lot of their bigger connections you didn't, and I was kind of waiting for that too, like other people said. You guys had, yeah, so you guys had given. Oh, and in the rebuttal he mentioned the straw man arguments, and that just kind of led me more to them too. So, but I did think it was close in terms of evidence-wise. Like everyone said at the end, I just had to kind of go to them.
Okay, thank you.
Hi, I'm Gabby.
Hi, Gabby.
So I voted for the government, but this was my favorite debate. You guys were all awesome, and I'm not just saying that to make you guys feel better about yourselves. You really did a really good job. I really appreciated how you guys spoke clearly, and like I feel like you guys were easier to follow than the government. You guys spoke kind of fast, and like Austin during your cross-examination, I had no idea what you were talking about, but you sounded so confident that I was like, I'm just gonna like go with what he's saying right now, even though I have no clue what he's saying. I really liked how you opened up with the analogy of if you were to be told that there was a 90% chance that you'd get in a car accident if you drove your car, like that you most likely wouldn't drive your car. I wouldn't drive my car if someone told me there was a 90% chance of getting in an accident, and that you said that just because a model isn't 100% accurate doesn't make it inaccurate. That really stuck with me. And then, Stephen, when you started talking, then you brought up the whole IPCC and Al Gore statements of that, like, the ice caps would be melting by 2013, yeah. And that obviously wasn't the case. And so I was like, you know, siding with the opposition at that point. I was like, yeah, you know, these models are inaccurate, like we can't trust them. But then during your cross-examination, when you got questioned, all your answers started off, well, like, I think or I believe, and so then it was kind of like, oh, I don't know if you really know. Sure. Yeah, I couldn't really like trust it, and I wanted to. And then basically, I think Tao, you won it over for me. But you guys all did a really, really, really good job. And like someone said, like, Tice, you really could be like I could see you being like a politician. You're very like. I get more sure. Than 0 votes. Anyways, you guys were all really good.
Thank you. Hi, I'm Sol, and so for me, one of the big things, just like starting off when Austin, like you did a really good job just establishing from the get-go that it had to be like the models had to be reasonable enough. So that like kind of set a criteria for the debate where it wasn't, you weren't arguing about the perfect accuracy, because like if you guys had been arguing about that, you guys would have had a much easier job. So I feel like you guys did have a difficult job just by the way that this debate was even worded, and also like the criteria was preponderance of evidence. And I think that you guys did a really good job like knocking down a lot of your guys' evidence. Like Tao, you did an amazing thing like using his source against him. I thought that that was excellent, how you actually proved like, well, isn't your source saying what I'm trying to say? So I thought that was really powerful. I also thought that something you guys did really intelligent was that you guys drew a lot on the accuracy of current models and how like currently like we're in the process of all of this is happening and we're getting so much better. And you guys didn't address that as much. You just focused too much on the past for me. Like, I think it was really relevant to bring up the past, but you had to tackle the future a little bit more. And Stephen, I feel like you gave too much ground. Like, you started off your speech by saying, like, yes, there have been huge advancements. You even, like, emphasized huge. And I was like, well, why are you doing that? Stop. Like, please, like, be more firm. I felt like you weren't firm enough in what you were trying to say. And then also something that Tao said that really stuck with me was that we don't judge intelligence based off of what they don't know. We judge it on how much they do know, and I felt that that was really intelligent because that's like kind of what they were trying to do. They were trying to focus on what the models didn't know versus how accurate they really were. Just overall, I felt like you guys have the preponderance of evidence and just did an overall better job with your argument. So.
Yes, please.
Hi, I'm Chloe.
Hi, Chloe.
First of all, good job back to group. We're dead now. I want to say I'm proud of all of you guys. You're very extemporaneous. Everyone, you can tell that each one of you put in a lot of work, which was very clear. The reason I granted adherence to the government was, in fact, because of Tao, particularly her kind of rattling off of evidence based on the criteria of a preponderance of evidence. But I do want to point out that the opposition team had some strong points, and they were kind of going there, but I needed more. Stephen, you relied a lot on that 46% fact. You kept repeating it, which was good, and it should have been reiterated, but I needed you to add to that. Because they kept building up their like evidence, whereas you had your chunk that was good, but that was it. So that's, I think, where, and like the smoke and mirrors a little bit. That's how kind of people lost your vote. And then additionally, I thought that, Tice, I liked how you kept your composure in your speech. I thought that it was a good way to kind of break down the argument. I liked how you took the time to explain why the clouds, why they're kind of like unpredictable. I thought that was important. You guys overall, I think, did a better job of connecting and relating things to the audience than the government, I would say. However, they had credibility because of their speaking. People said it already, so I don't need to repeat it. But I think overall you guys all did a good job. I mean, you were well researched. I also think that not having a number to put on like define accuracy, I think that also kind of hindered you guys a little bit. So good job.
Yeah, it was a fuzzy concept, wasn't it?
Yeah, it was a really fuzzy definition.
Yeah. Yes, please.
Hi, I'm Maral.
Hi, Maral.
So everyone's pretty much like covered it, but I just want to say this was actually really my favorite debate. And each one of you, when you started talking, was like, oh, they're the best. And I was like, no, they're the best. Tao, I was really surprised. Actually, you're like a boss. I'm just going to put that out there. You did a boss? Yeah. Sorry, I had to say it. You are. I thought it was cool that you were both, you and Austin were both very extemporaneous. Austin, I can tell you're a debater. Like, you just like killed it, those strategies. You guys also... You didn't just give a great presentation, you really knew your facts, like both of you, and that was great. You guys also did a really good job, though. I honestly think, in terms of like making the case, they had it easier. I think it was way easier to argue from their end, and obviously like every point has a counterpoint, but I think by default of the argument, it was easier for them to make stronger counterpoints, which they did. But I think that if maybe you guys had their side, it would have been a different outcome, but overall you all did really well and it was great, and Tao, you're great.
Thank you.
You want to say anything?
Yeah, I want to. Is it about to run out? Let's see how much time we get. I want to focus for a moment, if I could, because it was such a wipeout. I feel really bad for you guys. And I want to ask you what you thought you did wrong or could have done differently, or what? Because I looked at your briefs. They weren't long, but they were pretty decent, right? They got at the heart of things fairly well. What do you think now that you've been beaten up by 20 people and an experienced debater? What would you do differently? What do you think happened here, Stephen?
For me personally, I think it's the cross-examination. I wasn't really good with that, and also my rebuttal I think was pretty bad.
Yeah.
That's just my and as a lot of people have mentioned, they really set the criteria really well.
Yeah, let's talk about content a little bit. You talked about, Professor Clark from Reading, and then she sort of, and then you talked about how Gore's, that was your big crowning moment, that the ice caps really didn't melt, and that he was so wrong. And then you did the Cato thing with the 46%, but you didn't, this was Chloe's point, you didn't really come back with any more after that and anything to add to that, and that was 2011, right? So, and they were coming up with greater sophistication in their model, so how do you think you could have handled that better?
For me personally, I guess more experience, man. Really.
Yeah. Yeah, the cloud thing was interesting too, I thought. And I thought they're very difficult to account for. And I don't think that they necessarily handled it well. I think that what happened, I think you saw it, is that even if you were evenly matched, their certainty with which they commanded their evidence and their cross-examination and their rebuttal made the difference for that. Do you have any afterthoughts? Because I want to try to help you. I feel the worse for you guys because you got shut out. So I feel like I'd like to say something to you guys now so you don't walk out of here feeling like, ooh.
I lost plenty of time.
Yeah.
Well, I think what it came down to is the fact that I would say that they presented their arguments in a more, for me it was almost aggressive, but it was at least
dynamic.
Yeah,
Can you say it that way?
It sounded more convincing, and then even though if you don't look at what they're actually saying, if you look at the way they're saying it, people are more inclined to
be
listen to
persuaded by that. Do you think you can up your game? Can you be more passionate and persuasive in your delivery?
I think I could. I think starting point is I'm not, when I'm talking, I'm not the most passionate person.
Yeah.
With regards to computer models predicting climate change. But
yeah, I understand. Okay, I'd like to get some feedback from Ian, please.
I wish I had more time. I actually have about 1,000 things to say about this one. I think this has been the best round I've seen so far in here. And I actually kind of slightly disagree, Professor. I don't think it's necessarily what these guys did wrong. Sorry to everybody else, but I would honestly say I would put these two against pretty much anybody in this class and expect to win. That was a very impressive showing. The only problem is, again, you're against someone who's on the debate team. And also, Tao, I'm stunned by how good you were in this round. Normally I try and say a lot of bad and horrible things about all of you, but I don't have that many. I think this is a really, really good example of very, very different speaking styles out of every single person who presented. We got extremely analytic out of Tao. We got very dynamic out of Austin. We got extremely a simple breakdown out of Stephen. And we got a very authoritative stance out of Dice. I thought that everyone did a very, very good job presenting. And I am really, really struggling to say mean things about you guys. I can't find any, really. I was really glad that normally fact rounds you tend to see a lot of ethos, and we actually saw a lot of logos, which is extremely refreshing on both sides. Again, I don't really think that there was a lot of stuff that you could have done better per se in the context we're in, which is a classroom, first time speakers, and all that good stuff. I think that you guys did an extremely good job. Stephen, I was very impressed. Like, I think during your speech you gave a little bit more ground than your cross-examination, but I'm stunned that in your cross-examination, against who's possibly the best cross-examiner on our entire debate team, you gave almost nothing. Every single time he tried to get an answer out of you, you said, you dodged around it. You never actually fully said, no, you know, you're right. You just kind of wove around it and actually still held up your side, and I thought that was very good. Geez, yeah, I'm going to try and break this because, again, like, I don't have time to say everything I would love to say. But, yeah, pretty much we're out of time, so I would just say freaking great job from both sides. It was really impressive. I'm really shocked by how good this
thank
was.
you to the leader of the fact group for a good job.
If I can say one more thing, actually,
Yeah.
I would say one of the things I'm actually most impressed about is not actually particularly the debaters, but the audience this time. The analysis that came out of all of you this time and the things that you guys caught on to and the points that you guys iterated were actually really impressive this time. It seems like you actually are kind of understanding the dynamics inside debate, and you caught a lot of the pertinent issues and a lot of the pertinent things that they did to get adherence granted. So well done to all of you as well.
Yeah, I want to say one last thing about that. It's just a sort of a PS on that. I would like us to also be looking not just at authoritative and impressive delivery, but also equally at listening to the content too, and and making decisions there too, and not just being blown away by impressive delivery. But I agree with Ian. This was a really fine debate. Could I speak with the value and you a little bit after class about the science debate coming up?
Do not forget to turn in your Scantrons.
Yeah.
Just put them on the front desk, please, before you leave. Oh, or that. No. Are you a senior? You're a junior. You need to join the debate.
No.
You need to join the debate. No, you don't have a choice. I mean, you need to join the debate.
I tried so hard that I already tried.
No, I just hate being, I'm okay with arguing, but I'm like, I hate being judged.
Tell you what, can you give it a shot?
I told her just come one practice.
You really should. Because it's not that you could be a debater. You could be a very good debater. If that was your first, freaking full on, you really should join. Because I think you could be a top level debater. If that was your very first time, I'm stunned. I really am. And it's not just the analytics, it's the way, it's everything you did, your sheer reputational style, and the off-the-cuff delivery. I mean, you've already shown yourself to be better than some people who actually compete. You really should join. It's not like you're in front of 500 people. You're in front of like 3. It's judges, 3 judges. This Thursday is the last debate, or the last practice of the year, so you can meet some of the team and kind of see a little bit of what we do. I really think you can actually do very well, and you might enjoy it. Thursdays from 6 to 8 p.m. During the rest of the school year, it's usually Tuesdays and Thursdays, but because it's the end of the year, we're just doing Thursdays. But next quarter will be the same, Tuesdays and Thursdays from 6 to 8 p.m. It is in bunch 1221B.
I would say
1221.
No, you did better. I really did really good.
Yeah, I would strongly recommend joining. I mean, like, I really do think you can do excellent.
Really good. I think it's just like I expected you to be really good because you're on the debate team, and I wasn't expecting.
It was a good debate. She's better.
Because I'm like so stuttering.
You know, to be honest, I'm really impressed with how you're playing.
Thank you.
I agree with some of the points the scoring didn't represent the total program. Because I think you guys clearly won, but I don't think the number of ballots are close right ones.
I know you want to really? I thought
Yeah, I was going to ask about
you didn't qualify the rest of the
I don't know what else you write about.